Hello there everyone and welcome to this workshop on market basket analysis. My name is Valentine and I'll be your instructor. In this workshop, we'll get started learning about the objectives of the session. After that, we'll get to talk about important market basket analysis concepts that we would want to know and also implement. Then we'll also, after that, go through a practice session where we implement those concepts we've learned using the Python programming language. Then towards the very end, we'll talk about the next steps. So let's get started. It's also important to talk about the prerequisites. So if this is your first time going through a workshop in Python, this workshop assumes that you already have some knowledge of the Python programming language, considering that it's what we're going to be using to implement the market basket analysis concepts that we'll go through. So it's important that you have that before we continue. If not, you could always consider going through some past workshops on Python fundamentals that we've done, as well as data wrangling and data analysis. So yeah, so that's it in terms of prerequisites. So let's get started. By the end of today, we are expected to have achieved these learning outcomes. We should be able to explain what association rules are, as well as item sets when it comes to market basket analysis. We should also be able to describe the basic process for performing market basket analysis. And lastly, we should be able to find association rules that would help us to be able to just solve for different data science problems that we might have within our organization. So sometimes you might be asked as a data analyst to find ways to help an organization to maybe increase revenue. So one of the ways that would help you to find a solution to that question or research question that you'd get would be what are called association rules. So yeah, so by the end of today, or this workshop or this course, you should be able to say that you have achieved these learning outcomes. So what is market basket analysis? This is a type of analysis that allows us to be able to identify the strength of association between products purchased together. So for example, if you have a data set that contains transactions data with regards to customers on what they purchased, then we can perform market basket analysis to identify which products are likely to be bought together. For example, we might have a transactions data set of grocery. And one of the things that we could be able to do is to perform market basket analysis and identify which grocery products are likely to be purchased together. It could be that potatoes and watermelon, after doing our analysis, seem to be the products which are likely to be purchased together, and that could help the business itself be able to think about strategies that they could use when it comes to selling that product, whether to increase the prices of those products or whether to decrease the prices of those products. And in some other cases where maybe new products are being brought into the market, they might even decide to bring in a sample of a new product and include it as part of a bundle or package with those products that are being, those products are likely to be purchased together. So market basket analysis allows us to find those associations of those products that would be purchased together. So in that process of performing market basket analysis, we would normally create what are called association rules, which are generally if and then scenario rules. Like for example, if bread is purchased, then milk is also purchased. And these rules will be derived from frequencies of co-occurrence in the observations or in the transactions data that we have. For example, we might say if item A is purchased, then B is likely also to be purchased. Or just to give some more realistic examples, which real examples of if-then association rules, one would say this is also an association rule. If customers buy a smartphone, then they are likely to buy a protective case. If customers buy milk, then they are likely to buy bread. If customers buy a burger, then they are likely to order fries. If customers open a savings account, then they are likely to open a checking account. And yeah, so there are many other scenario rules or if-then scenario rules, but these are what we call association rule. Like a case for, let's say, if customers buy a burger, then they're likely to order fries. That is an association rule. And the beauty about it is that once you are able to ascertain that that is likely to happen, then one could provide recommendations to a business. And a recommendation could be that you would provide a combo as a product. So you would combine maybe burger as well as order and fries and into a bundle or into a combo or into a product by itself and price it maybe a little bit maybe higher or a little bit lower depending on the business objectives, then have that in terms of as a new product. But generally, market basket analysis just allows us to be able to identify those patterns of occurrence within transactions data. So why market basket analysis? Cross-selling and upselling opportunities. It helps us to be able to identify those opportunities within data. We can be able, and as a result, to create targeted promotions as well as bundles. Customer segmentation and personalization. You're able to also identify those different segments of customers and be able to personalize marketing strategies and product recommendations. You can also be able to optimize merchandising and inventory management and perform and also optimize inventory management in the sense that when you realize products which are frequently purchased together are let's say A and B, then you can have those products placed next to each other. It's also a reasoning behind what supermarkets normally have. If you go to buy maybe sugar, you'll find that there's next to sugar you have dough, like flour, not dough, flour. Could be that you have flour that can be used for baking, flour that can be used for pastries. So you have sugar, you have flour, or you also have maybe something else like baking products right next to those products. That way, you're able to optimize the space that you have altogether. Operational efficiency and cost reduction. So you're able to reduce costs by, again, helping customers be able to, purchase products which are related to each other. But at the same time, you can also be able to increase the you're able to increase the likelihood of customers purchasing those products, and that would also in turn have an effect on the number of products of those two sets of products that you sell within your organization. But again, products can be not only in retail, it can be in different contexts. It can be, as mentioned earlier, could be within the food industry, could also be within healthcare, it could also be within just different sectors. So the concepts would still remain the same. Another reason would be market basket analysis insights for pricing strategies. So once you're able to discover that products normally would be purchased together, then you can adjust pricing based on those insights. And also new product development. You can introduce new product or variants that complement existing offerings. So in addition to, let's say, a particular bundle, an easier way would be to introduce another product that's related to those products as part of the bundle. You tell people, buy this particular combo, which has products A, B, C. Yes, product C is the new one, but it's likely that whenever A is purchased, B then is purchased. But you take advantage of that association of those particular products to now push this new product into the market. And I think in many cases, you might see this happening in businesses. It's only that sometimes you don't really so much think about the mathematics that happens, that how goes behind the scenes. So in applications, I think I had mentioned earlier, but in retail, for example, you can apply market basket analysis. And in such a situation, in such an industry, as an example, you could have customers, you can discover that customers who buy diapers often buy maybe baby wipes. So you can place those items near to each other or offer bundle discounts to increase sales. Telecommunications, you might uncover that customers who subscribe to high-speed internet are also likely to subscribe to streaming services. So you can offer packages that combine those services at a discounted rate, thereby increasing the number of customers who purchase those particular products. Banks, customers with a savings account might be likely to benefit from maybe credit card with rewards. So you can target those customers with maybe special credits and credit card offers, etc. Insurance, you might discover that customers who buy home insurance also often purchase auto insurance, maybe because they already have cars, and that will be again from data. And as a result, what companies within the insurance industries might do would be to offer bundled discounts for customers who buy both policies. Medicine, patients receiving maybe a certain medication for hypertension, maybe they might often need a specific type of dietary consultation. So upon discovering that association rule, you could have some integrated treatment plan combining medication as well as diet adjustment. So there's so many use cases of market basket analysis, but these are just a few use cases. By the way, as market basket analysis in some context is also referred to as associative mining. So that is also something that you might hear in some cases. Steps to performing market basket analysis. Let me remove the underscore. So steps to perform market basket analysis would be the first step when it comes to data. So you might have research question. Once you've understood your research question really well, you'd then decide to do analysis. First of all, you'd need tools for performing data analysis as well as market basket analysis. Pandas works well for data manipulation, a standard library for that. But then MLXtend is a library in Python that you can use to now determine or to find or to identify association rules. So not determine, but generate association rules from data sets that you might have. So you need knowledge of how to work with MLXtend, and we're going to also see how to do that. So the first step, install the necessary libraries. The second step is to load and prepare data. So the data set that you would use would be slightly different from what you conventionally use. The data set format that you'd have would need to be in transactional format, so where you are going to be having actually show you this later. So you need to have transactional data, so not just data like the way we would have. You need to ensure that it's in a format that presents now transactions in an easier way. So for each and every transaction, I'll get to showcase that in a few in the practice work. Once you have loaded and prepared your data set, you need to find what are called item sets. We'll also get to talk about them. And then to find those item sets, we normally use algorithms, which will use a specific class from MLXtend to be able to determine the item sets from the data sets, from the transactional data set that you're going to work with. While you are getting the frequent item sets, there are metrics that you need to take into consideration. The first one is called a support value. We'll talk about that. So when you're finding an item sets or the most frequent item sets, you would need to set what is called a support value, and the support value would be dependent on the whatever use case that you might have. You'd also need to, after finding the frequent item sets, you'd then generate what are called association rules, the ones that we've talked about. If then this is purchased, if this, then this is also purchased. So you need to generate those rules from the frequent item sets that you have gotten, and you would, upon generating those association rules, you need to sort them by what is called confidence value. This is another metric, the second metric, and we'll also introduce a third metric. So once you have filtered those association rules using confidence value, you would also need to also filter them by what is called a lift value. So we'll have three metrics: support value, confidence, and lift measures or evaluation metrics for this particular case. There are a few other more, but these ones are the most basic metrics that you would find helpful when it comes to identifying those association rules that would be helpful for organizations. So these are the steps. Just note them in your mind. You can just know: install libraries, load and prepare data, find frequent item sets, association rules, as well as filter by lift. So we'll go through each and every step in our practice work. Now, before we go through the practice work, it's important to go a bit more deeper into the different terminologies that we've talked about. We've talked about item sets. We've talked about, frequent item sets, but item sets. We've talked about association rules, like what are they? We'll also elaborate a bit more. We've talked about support value, confidence, and lift. We'll also get to expound more on what those entails in the next 5 minutes, so that you're in a good position to continue this learning journey. So association rules. So as mentioned earlier, these are rules that indicate the likelihood of items occurring together in transactions. So for example, an association rule can be as the one that you can see in the first example. If beer and chips are bought together, then dip is also bought. Another one would be if bread and milk are bought together, then eggs are also bought. Another association rule would be beer and chips are bought together, then dip is also bought. So our main objective for market basket analysis, in many cases, it's to identify which of the association rules within some transactional data sets would be most helpful in answering a research question. A research question can vary, but in many cases, it's usually to identify which particular products are sold together. So yeah, so that's one thing to note. That's an association rule, just a rule that indicates the likelihood of items occurring together. There's item sets. On the other hand, item sets are basically the sets of products that you find within the association rule. So they are the sets of items that appear together in a transaction. Like for example, beer and chips. In this case, it's an item set by itself. Dip is also an item set, but it has only one item. The one on the left-hand side, it's beer and chips, has two items. And the item set, they come in two types. There's what is called an antecedent and a consequent. On the left-hand side, we usually have the antecedent, which means that if beer and chips are bought together, then dip, which is the consequent, would also be bought. And you can also have a consequent that has multiple items. Not just dip, it can be maybe dip and chips, something of that sort of, dip and something else. Or, for example, two, bread and milk are bought together, then eggs are also bought. So the idea is to just have an understanding of what item sets are, as well as association rules, and also just these two terminologies of antecedent and consequent. So the first one, the first association rule, if customer buys beer and chips, then they are likely to buy dip. A second one, if a customer buys bread and milk, then they are likely to buy eggs. The third one is if a customer buys beer and chips, then they're likely to buy dip. All right, so we've gotten a few concepts. Hopefully, we are good to go to the next now. We're now going to go through the metrics. Now, these are just the basic concepts that you need to understand. We're going to go now through the 3 different metrics. We'll define them mathematically, but we won't go deeper into the mathematics of how you work with them. But I'll give an example of how you calculate the different metrics. So we'll start off with support. Support, it's a measure that we can be able to use for, say, for example, for an item set. So for example, we can say the support of an item set is defined as the proportion of transactions in the data set in which the item set appears. So for example, the support value, which is a metric or number, for item set A would be item set, the transactions, the number of records containing item set A divided by the total number of transactions. So if there are 100 transactions within the data set that we are working with, and item set A, which, remember, it's that collection, it could be one item or multiple items. So assuming we are working with just an item set with one item, dip, the support would be, if dip appears in 3 transactions out of the 100, then the support would be 3 out of 100. So generally, so another example over here, let's say assuming we wanted to calculate the support for this item set called bread and milk. So to find the support for item set, that item set, we can count the number of transactions that contain bread and milk, which could be in our case, assuming we have 10 transactions, and bread and milk item set appears 4 times in transaction 1, transaction 4, 5, and 6. Then in such a situation, we would have the support of this item set be 4, which is the transactions containing the item set, divided by the total number of transactions, which is 0.4. So generally, you'd have 40% of all the transactions in the data set. So that's the conclusion. Once we get to 0.4, the interpretation is that 40% of all the transactions in the data set contain both bread and milk together. So that's one particular example. In another case, you might want to maybe to perform or to determine the support for butter and jam, that item set. Then we can find the support for that item set. Again, similar, 4 divided by 10, which again would mean that 40% of the transactions in the data set contain bread and milk. The first example that I've given you about dip having 3 out of the 100, that would mean that 3% of transactions in that particular data set contain bread and milk together. So I hope that explanation served well, and then we can continue. All right. Just one more thing, interpreting the support evaluation measure. Sometimes you might ask, what is the best values for support? But generally, a high value of support just indicates that the item set is purchased frequently together in transactions. For example, bread and milk, when it has a support of 0.4, it means that 40% of all transactions contain bread and milk. Low support, it just indicates that the item set is rarely purchased together. So in the data set itself, in the entire data set itself, it means that if it has a low support value, it means that that item set is not frequently purchased together. All right. The other metric, confidence. Confidence, we would use it to just evaluate the strength of association between 2 items in an association rule. So we might be able to determine the likelihood of occurrence of the consequent, given that the antecedent is also present in the transaction. So, for example, in our case, to calculate the confidence for bread if bread is bought, then also milk is bought. To calculate that particular the confidence value for that particular for that particular association rule, we can take the support. It's actually usually confidence is usually as you can see what I have highlighted there. It's usually the support of what you want to determine divided by the support of now one of the item set. So in our case, to find the confidence for the rule bread, if bread is bought then milk, then we can calculate the support of the item set, which is what you see there, bread and milk, and the support of bread and milk. So we get the support of bread and milk, it's 0.4, and support of bread is 0.7. Then we divide 0.4 divide by 0.7 and we get 0.571. And in this case, the interpretation would be if a customer buys bread, there's approximately 57.1 chance that they will also buy milk. You know, it could tell us that 57.71%. I mean, you want to have a confidence that's actually 100%. But in many cases, you may not necessarily get 100% confidence value. So you need to work with maybe higher values of confidence, depending again on your situation. In some cases, in maybe specific niche, for specific niche products where you do not have many transactions, then maybe confidence level slightly lower might be okay. This is an interpretation. Higher confidence indicates, higher confidence value indicates that the consequent item is frequently purchased when the antecedent is also purchased. What's on the left or what's on the right, it's highly likely that it will be they will be purchased together. So for example, confidence of 0.8 for butter to jam means that 80% of the transactions that contain butter also contain jam. Low confidence, it just means that the association between X and Y may not be significant. So maybe confidence level of 0.2 would suggest that only 20% of the transactions containing X also contain Y. Lift. It's important to note that this is another metric that we can use, and we usually use this particular metric to quantify the strength of a rule in terms of how much better the rule performs compared to if the antecedent and consequent were independent. So this it takes into consideration of it takes into consideration of previous calculations, but again, this is just a maths of it, how we're able to calculate. So for example, if we have beers, diapers, and chips occur together in 2.5 transactions, 2.5 transactions would be the support, and beer and diapers occur in 10% of the transactions, and chips in 8% of the transactions, then the lift would be 0.025 divided by, then again, 0.1 times 0.8. And you get 3.125. So again, the conclusion would be that the occurrence, you get 3.125. But again, when it comes to market basket analysis, we always want to have lift values greater than 1. And this is why, because lift values, actually we'll start from the bottom. Lift values less than 1 normally would indicate that the rule has a negative correlation. So for example, if we have a lift of 0.816 for this association rule, it would suggest that customers who buy bread are less likely to buy milk compared to what would be expected if the two were independent. If we have, let's say, lift values equal to maybe 1, it would indicate that antecedent and consequent are independent of each other. So none of them, there isn't any influence in terms of whether this, when this is bought, this other one is bought, this other item set is bought. Lift values greater than 1 just indicate that the rule has a positive correlation. So if we have a lift of 1.143, it suggests that for that customers who buy butter are 1.43 times more likely to buy jam compared to what would be expected if the two are independent. So this is usually one of the last steps that we apply when it comes to market basket analysis. Some general considerations when it comes to working with these metrics. So I'll even just go behind this back a bit and display this step. So you can see here we use algorithms to find the frequent item sets, and we set a minimum support value. So I'll talk about just quickly why we would want to choose, the best value to choose for support value. We also set confidence value and later lift. So for example, for a case where, so support values, initially we might want to use maybe a range between maybe 0.1 to 10%, depending just again on just many of the factors that we had mentioned earlier. But in some situations, but in many cases, it's usually 0.1 to 10. But in some cases where you are working with maybe, actually it depends with also the specific industry, because for niche products, maybe you might want to work with maybe a lower support threshold. But just looking at values for support, normally you adjust them and set them for just between that range. Confidence thresholds typically range from 50 to 100%, but you can begin with 60%, then assess the number of and quality of the association rules generated. If maybe too few rules are generated, then a lower confidence, then you can lower the confidence threshold or the confidence value. The lift value, we normally work with just greater than 1. So you'd want to ensure that maybe lift is greater than 1, which just would suggest that we are able to just capture strong associations. But if it's less than 1, we would want to capture weak associations. So generally, you just start with just those particular standards in terms of the values, then you adjust accordingly. The algorithms that we can use are these ones for being able to find the frequent item sets. Our focus will be using the a priori algorithm, which allows us to be able to find frequent item sets. And it has its own way of working. So for example, it's able to determine the frequent item sets one item at a time using a step that's known candidate generation. There's also ECLAT algorithm or ECLAT algorithm, which uses a strategy called depth first search strategy. We can use it in cases probably where the a priori algorithm may fall short of being able to generate item sets that we would want or we would need. Again, sometimes you can compare you can do your analysis with the different algorithms and then compare the results generated. But again, for the ECLAT and FP growth, the computational, they're usually computationally expensive and not usually used in many cases. Right, so this particular point, you can take a break, pause the video, take a break. If that was too much, try to understand what we've just covered. And let's move on to our practice work. So go to the description section of this particular workshop. Of course, click on the link that's in the description section, the practice resource link, and then it should take you to a page that looks like this. Then click on this sample practice resource, and you should be able to get a sample practice resource that looks like this. All right, so once you get here, just save a copy in Drive. Go to File, then save a copy in Drive, and then we can get started. I'll use my practice notebook. I won't use the other one. Practice has more challenges. Again, you can always become an afterwork member and get more resources. All right, awesome. So once you have done that, I'll just open mine in playground mode. You don't have to. It's like a sandbox environment where you don't make any changes to the notebook, the original notebook. So once you have a copy, let's connect our notebook to Google servers so that we're able to run the code that we run in this particular notebook for that purpose. And then we are going to import the prerequisites that we need. Connecting your notebook to Google servers may take a few seconds. So we'll work with pandas as mentioned earlier, and then we are going to also import MLExtend, and we are going to use the a priori algorithm as well as this particular association rules function to be able to create association rules from the frequent item sets. Item sets will generate them using the a priori class that we have here. So let's run this. Just run it. We'll go through the actually 3 examples. So we'll start off with the first one. Let me zoom in a bit. Awesome. So starting off, we are going to load a data set that contains transactional data. I have already, to make it easier for you to just go through and learn the concepts that we are going to learn for this session, I have already prepared this data set. So we won't prepare it that much. We only just do 2 or 3 steps for preparation, not that much. So this is the data set that we have. It contains transactional data set. You can just ignore this warning. Don't worry about it. So this is the data set. It contains products. So you can see on the headers are actually products. So it could be bread and milk, etc. But here we have, these are just names of products. And for the records, we have either zeros or ones, respectively, for each and every column. So this is, the records actually represent transactions. When you see a 0, it means that product wasn't bought. That's adjustment wasn't bought. Afternoon with the baker was not also bought. Bacon was not also bought. So if you scroll to the right, you should be able to see just values as shown. And you can always consider maybe even just doing a random sample of maybe 10 records to be able to see whatever that you might want to see. So if I get a sample of 10 records, I can be able to see that this is my data. And it has quite a large number of records, even like 6,000 transactions, etc. And you can see here for this one, you might not be able to get this value that I'm getting. So I'm getting 41 to 27, but you might get other transactions because it's randomized. You can see that I have this record toast. So for this particular transaction, toast was bought. So, and also for this transaction, Alpha Jores was bought. These are just different products. So if you have maybe for a transaction, this item and this item was bought, you'd have 1 and 1 over here. So you need to ensure that your data set is in such a format that we can later use for market basket analysis. We'll go through some 2 other concepts, some 2 other examples that will also take us from working with maybe a raw data set and into just getting into this format. It's also something else to notice that the data set can be in this format, or it can have maybe true or false values. For the zeros, you could have false. Then for 1, you could also have true. So just depends. So once we've done that, we can convert this data set into a Boolean data type. This is actually what I was mentioning. So if let me see if I can be able to print this out head. Which you can see what I was mentioning. Sometimes you could have false and true values. You could decide to also have it as shown. All right, so either of the 2 would work. You don't necessarily need to do that, but yeah. So let's go to the next step. Once we have a data set that's well prepared, the next thing that we need to do is to generate the frequent item sets, and we use the a priori class that we had, and we create an object, and we pass this data frame that we have created, and we define our minimum support. We mentioned that support, you can start from 0 to 10. So it's not 0, well, either it's 1 to 10%. So here we have set it to 1%, and we want just to display the column name so that we're able to see the item sets themselves in terms of column names. Then we we create those frequent item sets that's shown. It's not that hard. And as you can see here, we have our item sets. We can always also silence this error, so don't worry about it to be appearing every now and then. But if you run this in a different environment, then it should work well. Not sure why. But yeah, so here we have item set and the support. So item set baguette, it means that in all the transactions, quite a large number of transactions, baguette appeared, 1%, in 1.6% in 1.6% of all the transactions, etc. All right. Once we have done this, determined our frequent item sets, we can generate the association rules. So we use the association rules function that we got up there. You remember it? Yes. And we pass now our frequent item sets, and then we use a metric lift. So we want to set its threshold to 1. So this is how we do it. We can actually do this. Yes, we do this, but again, once we have we've gotten the minimum threshold, we can also sort the confidence values from the greater confidence values from 1 to downwards. So that's what we're doing here. We're actually doing two things. We are creating association rules, and we want to create and get the ones that have a lift value greater than 1. And also we sort in order to get the confidence values from top to bottom. And yeah, so we run this. And this is what we get. So here we are able to see that we have, these are 10 items, and we have sorted them by the confidence levels. So it's highly likely that, like, for example, for the first association rule, of if toast is bought then coffee, there's 0.7% confidence level, which means that it's highly likely that when toast is bought, then coffee is also bought. We have also the supports for antecedent, consequent. These are actually ones that also contribute towards the lift value. But again, when you look at the lift value, which is over 1, which means that it tells us that the purchase of coffee is again influenced by the purchase of toast, rather than coffee's purchase being independent of toast. So so there's some more observations that you can see here, but these are the frequent item sets, not frequent item sets. These are the association rules that we might be interested in, and we could recommend further, maybe for further action. It could be that we might recommend that whenever, maybe just bundling this together would make much more sense. Like there could be an offer, or we could introduce maybe a product together with toast and coffee. We could decide maybe to increase the prices maybe of toast, because we already know that people will buy them together, and test out and see what that happens. So yeah, so those are the association rules that would work. Let's go through the second example. By the way, you can pause the video and work on the challenge if you would want to undertake that task, but I'll just go through the second case. So okay, I keep on getting this error, but again, we will figure out. It's, I think, caused by the ML extend library, but I think we can consider that. So yeah, so assuming that this is the transaction data set, so we have one milk. This is defined. It's defined differently. Like in transaction 1, which is 3 records over here, milk, eggs, and juice are purchased. In transactions 2, milk, juice, etc. are purchased. So to be able to convert this into the format that we had here, or here, we can, let me go and see, where are we? We can, first of all, let's run this. So here we are defining that we want to create a new column, and we want to use this column as the index. And as you can see here, we have this new column, and we've generally grouped the bread data frame, the one that we had, by transactions and item, and displayed the count of items. So that's what we have done, and that's what we are displaying here. Then once we do that, we can then perform some data pre-processing techniques. So here this is some complex code, can be one line, but generally what we are doing here, we are consolidating the items into one transaction per row. Here we have multiple transactions, or we have multiple rows within, we have one transaction happening across multiple rows, but here what we're doing is just consolidating those transactions to be just contained within one row, and we just displaying the outcome in a one hot encoded format, which you can see now here that we have this transaction, the first transaction, and we have chips, cookies, eggs, and juice and milk. So we're almost getting to where we're actually getting almost there to where we want. But again, we don't want 0.0s. We want to have either zeros or either ones, and this is where we are encoding now those values. So we don't want 0.0s, we want ones as shown here. Then once we get to here, we can still go further to have, so that we have our data set with true or false values, but we just decide now to just generate the frequent item sets. But here we increase our threshold. Here we have set 0.2. Actually here we had 1%, but here we have decided to use a different minimum support value of 0.2. That's 20%. And this is what we get. You can see that these are the transactions. And then we can then find the association rules and set our minimum threshold of 1, and also sort by the confident values. This step usually remains the same in most cases. And as you can see here, we have chips, milk, juice, etc. But we also have, you can see this combination has a lift of 2.5, which would mean something. But again, generally, rules like what we see here, what works, like we can see chips, this item set that we have here, and juice, they all show actually all the rules here, but we can still rearrange them properly. We can still display more, not just those 10. Maybe let me display 10 of them. Yeah, actually all of them have a confidence of 1, which would generally mean that they have what is called perfect confidence, meaning that the item sets on the left are, and the antecedent and consequent are usually brought together. So yeah, but this is an example. It may not necessarily be always the case. This is just a sample data set that allows us to be able to see what's happening. I had mentioned leverage. I had mentioned there are other metrics that we can look at, but these ones are not, they're usually complex metrics, not really covered, but the basic ones that work best are these 3 for just many cases. There's some observations that you can also go through. All right, example 3. We also have this other data sets, which you can be able to see, which will load in a few. And we're also going to do data pre-processing tasks. Like for example, here we have transactions actually. This transaction has green blouse, orange pants or pants, but these other products have 000, so which means they have none, which it means just missing values. So we can pre-process this data set so that it's in the format that we want. And that's what we're doing in this next step. We convert that pandas data frame into a list of lists, which we do here. We also use a list comprehension and also a pre-append function for that. It's a bit complex, but won't go so much deeper into that. Then we transform the list of lists that we get into a one hot encoded pandas data frame using the transactions encoder, which we have here, true or false. And then we could decide to further, actually here we also decide to delete the NaN column, so because we don't need it. And also we just, well, they're already it's already in true or false value, so I don't even need this, but you can still run it, it's okay. And then once we are done, we dropped that, we can be able to generate the frequent item sets using the a priori function. We set the minimum support 0.2, find the association rules, and sort them using the lift as well as the confidence values. And we can see here that we have undershot and shorts, which have a perfect confidence level of 1, which just means that they have a strong association, and also the lift value, it's also high, which again indicates strong association. So it's likely that those two products will be bought together. Earrings, Blue House, Blue Blouse, they have confidence of 0.83. So again, still high. Likely that customers who buy earrings are likely to buy Blue Blouse. Yeah, so there's some more observations here. All right, pause the video, then work on the challenges that we've provided you. Just it takes a bit of some more practice. Then once you're done, we can talk about the next steps. Okay, so the next steps, where do you go after this? So far what we have done is to go through what is important when it comes to applying maybe a type of analysis for businesses in just generally business decisions. And this type of analysis is usually what is it's an unsupervised learning type of analysis. It's still part of machine learning. In machine learning, we have supervised and unsupervised, and unsupervised learning, this is one of those techniques. I think the next steps would be, after you've done maybe projects on market basket analysis, we would recommend that you go through other types or maybe unsupervised learning workshops, maybe something like anomaly detection with maybe Python, just to be able to expose yourself to just strategies that you could use to create solutions for different kinds of data science problems. And yeah, so that's what we would recommend, and that's it. If you loved this workshop, if you did learn something valuable, be sure to give this video a thumbs up. And if you'd want to be informed when we post such future courses or videos, be sure to subscribe. All the best.